Hi folks, so in this video what we're going to be doing is completing a question from the 2024 mock. It's the exam craft company paper, and the question specifically we're going to do is section C question, question 3, based on the topic of surface geometry. So just going to read the question here. It says the 3D graphic to the right shows the roof of a building. The roof surfaces of the building are in the form of a number of intersecting surfaces. Okay, so we've got the blue kind of section top, red section in the middle, and the yellow surface at the bottom. The surfaces A, B, C, D, the yellow surfaces, have a pitch of 50 degrees to the horizontal plane. What that means is the angle that they make with the ground, any surface A, B, imagine C and D on the opposite side, are all at 50 degrees to the ground. While the surfaces E, F, G and H, which is all the blue surfaces, have a pitch of 60 degrees to the horizontal plane. So all those surfaces are at an angle of 60 degrees. Part A, draw the plan of the roof surfaces. Part B, draw the elevation. C, find the dihedral angle between surfaces A and B. And then part D, find the true shape of surface A. Okay, so looking at this, you can see here, we have to start off by drawing the plan. They actually don't give us the heights for all the elevation. That's why they give us the angles in here for the inclinations of the surfaces. So we're going to have to use those to get the elevation later on. But starting off with the plan, you can see here, I'm going to start right here at this point, and that line there has an angle of 15 degrees going downwards, and all sides there are at 120 millimeters because it's square. And then I've got the surfaces inside here. I've got the hidden detail surface, which is 40, and then outside that it's 10, and then this little square inside here is 10, and all these lines have a relationship that they're all parallel, all these ones are parallel, and so on. So, starting there, I'm going to set up an XY line. I'm going to set up the XY line just a little bit above halfway on the page. So I'll just get my set square here, just a little bit above halfway. So there's my XY line. I'm starting just a little bit below that then. I'm going to do a horizontal line. I'm going to pick a point out there. And on that point then, I'm going to measure an angle of 15 degrees. Reading around to the 15 degree mark. Right there. And now that I've got the 15 degrees, I'm going to draw my line and measure 120 millimeters. That's 0 as far as 12. Now there is other ways that you can actually do the 15 degrees. Okay, they often like to throw that at us. Sorry, to be in this direction. So if you get your 30 degree set square and position your 45 degrees like that, that also works as well. Okay, that's kind of coming from your axonometric. Lots of students mightn't think of that, so I'm actually going to do this using the sliding set squares method. Now that I've got one side, okay, I want to get two sides going perpendicular to that 15 degrees. So the way I like to do it is I get the 45 degree set square. I put it on my 15 degree line, make sure it's bang on it, and then I'm going to rotate the set square like this and draw a line down. Now, good sharp pencil is required here to be 100% accurate. Just sliding set squares along. Okay, and then I'm going to measure down 120 millimeters. As there, and same thing, I'm going to just do a bit of sliding set squares here now. There we go. Slide that all the way down till I get to the point at the bottom. Just gone off screen there a little bit, apologies. Check my measurements, make sure I'm 100% accurate. Yeah, I'm happy with that. Okay, so now what I'm going to do is I'm going to draw in my diagonals from there to there, and likewise from here to here. So there's my diagonals put in. I'm heavy in the details on the outside now, so we'll have the opportunity. Okay, just keep going there now. And maybe this one as well. Okay, there's the outside details headed in. And now what I want to do is I want to focus on the bit inside in here in the middle. Now, I can see that the lines are all going in these directions, okay, parallel, 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 and so on. This two are parallel with these ones, okay, and so on. I'm going to focus first of all on getting the inside square, which is 40 millimeters. Now, I find the easiest way to actually do this is to measure, or sorry, get a sliding set squares and go parallel off the baseline. I say the baseline, the lowest line, and I'm going to project a line from the middle across like that. Now I can use that line then because that's the center point, and to get the 40 millimeter square from the middle I'm going to measure 20 millimeters to the left and 20 millimeters to the right. Okay, and having done that, I'm now going to go parallel to the sides, and hopefully if I'm accurate, when I rotate around they should meet up. Okay, accuracy is good, happy with that. There's one, see what I'm like down here, happy with that as well. Now from there it goes out 10 millimeters, so just need to measure it on one side, and once again just going parallel. Just going to set these up properly again. So I will. I just have to move there, guys. Apologies. So sliding set squares, and then from here parallel this one. See what this turns out like now as well. Hopefully, if I'm accurate, they should all meet up. Tiny bit of inaccuracy there. That's okay. And then finally, the last little square you can see inside here is 10, which means I'm going to measure 5 and 5. So 5 to the left, 5 to the right, and the same thing again. So using the guideline on the outside first. I was going with that one, so that's the one I kind of used to start off with. So there's my vertical and my vertical. Rotate the set squares. See what we're looking like, horizontal and horizontal. Okay, now that I've all that done, start to heavy in the relevant information. So there's the very, very top of the object. Now I'm going to work onto the side. Okay, heavy in the diagonals as far as appropriate, there to there, and then this one to this one. Okay, and then the hidden detail underneath, as fast as we can, and that'll be our plan view completed. Okay. A little bit awkward in drawing, just a little bit of neatness and accuracy with our sliding set squares. Okay, and there's our plan view completed. Alright, now what we have to do is we have to move on to the elevation. So draw the plan of the roof. We've just drawn that in there with our hidden detail put in as well. Now to get the elevation, it says here, surfaces A, B, C, and D have a pitch of 50 degrees to the horizontal plane, which is the yellow surfaces, and we'll get onto the surfaces E, F, G, and H in a minute. Now, as you can see here from the elevation, the only bit of information that they tell us is the height for the midsection here, which is the red surface up here, this little red surface, and then this little blue kind of vertical panels here. So that red surface is 15 and the blue vertical panels are only 10. Okay, so 15 for the red and 10. They do not tell us the height from the XY line up to here, which is for the yellow faces, and they don't tell us the height for the blue face at the top as well. But they do tell us a bit of information about them, that they have an angle or an inclination to the horizontal plane of 50 degrees. So 50 degrees for the yellow surfaces and 60 degrees for the blue surfaces. Now, easiest way to work from this here is to use an auxiliary view. Okay, if I take my surface A here, which is my panel A, which is this one here, that surface right there, if I take that, I do have a true length. I actually have two true lengths. I have the true length here of the baseline, which is on the ground, and I also have where it's going up to, which is the hidden detail here, and that's the height of it as well, okay, or how high it is going up to. Even though I don't have the heights over here, they do give me the angle. So what I can do is I can look along that true length, which is resting on the ground, and I've also got the height here, and I will actually see that surface as an edge view when I put in the angle. So perpendicular to that, so it's like we're projecting out along it, so I'm going to project out there, and I'm also going to project out how high the A surface goes up as far as, which is there. And then I'm going to set up an X1, Y1. Just move there slightly a bit, guys, sorry, apologies. I'm going to set up an X1, Y1 looking perpendicular to it. So an X1, Y1, which will actually be parallel with the side face here. I'll go as far as here. So that there is my X1, Y1. And what's helpful here now is, technically, this point and this point, which are both on the ground, are now here. Okay, these 2 points, I don't have the height for them because I can't take them from the elevation. But these 2 points here, we are told that the surfaces, the yellow surfaces, all have an inclination of 50 degrees to the horizontal plane. In this case, my X1, Y1 is representing my ground. So I'm going to put my protractor on it. I'm going to measure an angle of 50 degrees. Switch over my pencil there. So there's the 50 degrees. And now, with that, I can now technically, what I've drawn here, when it meets this line here as it goes up, technically, right there, will be those 2 points here and here. Because I'm seeing the surface A as an edge view. Okay, edge view, I'll write in A there. So that's my edge view of A. And but what's helpful for me now is technically the height from here to here, that height right there, try to get the exact height, that height there is technically the height that I'm going to need up here in a minute. So now I can start drawing in that first part of my elevation. So projecting up my points from the plan view, I'm going to project up 4 points that are on the ground. 1, 2, 3, and 4. Now all those 4 points are going to meet up at these 4 points up here. 1, 2, 3, and 4. So project up all of those as well. 1, 2, 3. This one here. 4. Now, as I said, we have now determined the height of that surface because that angle in there was 50 degrees. I can take the height from here and I can mark it up on any one of those. I'll just mark it up on this one. It's the easiest one to start with. And all the heights of those will be the exact same going across. So now I can draw on that line going across there and I can connect all those up. So this one here connects to this one. So there's that first surface. This one here, which is this point, connects to this one. That's the hidden detail. Draw it in lightly first. This one here, connect down to here. And this one connects to the outside one. So heavying in my details there now. Heavy in my horizontal line first. And then my various inclined lines. And all the full heavy ones. And and then this one here goes in as hidden detail. Okay, there's our first surface done. That's the surfaces A, B, C, and D. Now we're going to work on to the next couple of surfaces, which are the bits in the middle, the red surface, and then this straight surface. So that's just measuring up 15 and then up another 10. Easy enough to do. So I'll measure up my heights there. So from the 12 up to 13.5 is 15, and up to 14.5 is the other 10. So do a line across there, and then a line across here, and then I have to project up the outside ones as well. So that one goes as far as there, this one, I've got this one here, and finally this one. So once again, heavy in what's important. I'll go heavy to there. This one is the hidden detail. Okay. Heavy in the outside ones. And then heavy in the hidden details, which will be, let's work on this one, sorry, make sure I get the right surfaces, yeah. That one there, and this one here. Making sure I didn't make a mistake. Okay, so there's that little next section. Now what we're going to do is working on the top surface here. We're going to use the exact same principle, but this time we're going to take an edge view of this kind of little section in here. Okay, so looking out along here like we looked along the ground as well. So this time I'm going to look out along this one. Okay, and I'm actually going to use the same line. What I will do here is going to highlight the heights that I took. So the first one here I'll just put in red. So that little red highlighter that I'm after putting in there, I'm just going to mark that up. Here on my sheet. Okay, and I'll write there, what I'm going to write for that one is H1, H1. Okay, so that they're corresponding. Now what I'm going to do is the exact same thing for the next section here. So just making sure I'm using the right pencil here. Okay, now the surface I'm focusing on is this surface here. Okay, so the same thing, that surface is also going to project out to our x1, y1. I can use the same x1, y1. So project that out. I can use the same x1, y1. So that will come out as far as there, and it goes up as far as these 2 points here. And that will go up. Just extend it out a little bit because I need it to match up. Okay, this is technically our point now that we're using as a guide, and what we're doing now is we're measuring an angle of 60 degrees. Okay, just use my protractor. I'm kind of fussing about the set squares. So 0 all the way to the 60. So there's my 60. Looks like it's close. It's a very similar enough height. Okay, and there's the 60, and once again I've got an edge view of that surface. So I'm just heavy in that. But what's helpful here, I'll go with a different color this time. Go with a green. I've now got the height from there to there. That height there, I'm now going to call that one H2. Okay, so that height there for this surface, that's the angle inside there was 60 degrees. I'm going to take this height, slightly smaller. I'm just going to mark it up from here. See the little line that I've done there. Using 2H. I've done it from this point here, so I'll actually just put a line up to that. And where it went through that line, I'll do a line across because that will be the overall height of it there. Okay, now all I have to do is I have to bring up 4 more points, which are 1, 2, 3, and 4. All those will go the whole way up. So there's point number 1, point number 2, 3, and this one here, 4. And it's simply a case now of connecting those up, and glue those in. So this one here will connect to the outside. This one in here is the hidden detail. This one here is to the outside. And then finally this one here. Okay, there we have it. Little bit tricky. Drawing it in, not too bad, but obviously determining the heights over here was a little bit tricky. Okay. Once again, I'm just going to correspond the green one with the green one. I'll just put in, probably should have put these on the outside, it would have been a little bit neater, but for the sake of the drawing, I'll just put it in here. So that's the green one there as well, and I'm going to write on that one H2. Okay. Next little bit of the question. So it says here, find the dihedral angle between the surfaces A and B. Okay, so we've got surface A here, and we've got surface B over here. What we're going to do is we need to find the dihedral angle, and essentially when we find the dihedral angle, we need the line that is common between the two of them, which is actually this line right here, that edge going from there to there. Okay, now what's helpful is I need to find the true length of that. So the only way I can find the true length of that is when I look perpendicular to it, and I'm going to set up an x1, y1. I'm also going to then pick 2 points that are actually on the ground for A and B. It's the easiest way to do it rather than bringing up all. Technically there's 4 points on surface A and 4 points on surface B. I'm just going to work and make kind of a triangle out of them. So looking perpendicular, I'm going to set up an x1, y1. And go a little bit further. I think that about there will be fine. So that's going to be my new x1, y1. And I'm going to project out all the points perpendicular. So this point here, I'll go out. This point, which is on the ground, one needs to go as far as there. And I'll bring 2 more points. I'm going to take them randomly from here. Okay, which is technically this point and this point. Okay. So I can move there very sorry. Lights back on. Now, all we're going to do is we project from the plan, we take our heights from the elevation. Now, technically, this point here is on the ground because it's just somewhere up here along this line. And this one here is also on the ground and it's somewhere up along this line. Okay, because they're on the ground, I don't take any heights because they're already on the ground. So technically, these 2 points are here. This point here is also on the ground. So that's that one there. The only one I need the height from is the line of intersection, which is that height there, which is the height from here up to here. So I'm going to take that height, there to there, and mark that height. And then I'll come down to here, project it out to the x1, y1, mark it up. And technically, I have now found the true length of my line of intersection. I'm going to write in TL there. Okay. More importantly, I'll have to connect this down to here, which is actually representing 2 lines. Okay. It's representing the point from there to there and there to there. Now all we're going to do is, now that I have the true length of my line of intersection, I can actually look along that true length to find it as a point view. Therefore, I'll see the surfaces then A and B as an edge views, and I'll get the dihedral angle. So set up, first of all, project out, and I'm going to project out the other one. Remember, there's 2 points coming from here, and this 2 as well, so that'll go out. And then I'm going to set up an x1, y1, sorry, not an x1, y1, an x2, y2. Okay, and actually just extend those a bit further, just to make sure I have enough room on the sheet. Okay, and all we're going to do now is, because we're at the x2, y2, we take our distances from the previous x1, y1 back. So, the distance from, I have 4 points, the distance from the x1, y1 to this point here is the same as the distance from the x1, y1 to this point here. So that's getting my point view of the true length. So I'll mark it out from here, follow it up. And that there, right there is my point view of a true length. Okay, point, view, TL, or technically my line of intersection. Now I have two other points, this one and this one. I'll take the long one first, that distance from there to there. I'm going to come up here, mark it out, and I'll take the short one next. So from there, mark it in to there. I'll mark that out as well. And technically, I've now found when I connect this one to this one, space inside is my dihedral angle. And usually you would, just extend the line a bit further so I have something to measure from. You would usually measure the angle. Extend that one as well. So for me, it's working out to be 100% accurate. 100, 110, it's working out to be 114 degrees. So 114 degrees. That's my dihedral angle between the surfaces. Okay, that's the section C part. And now what we're going to do is find the true shape of surface A. Based on my drawing here, I have a feeling that may go slightly lower than my page. So I'm just going to grab another sheet there, just to show you what you can do. You can get a bit of scrap paper sometimes, or just grab maybe an A4 sheet, depending on what you have today. You can get it and just stick it underneath like that. Then get a bit of masking tape to stick it down with. A little bit of masking tape there. Pull this down. Right, so you can see I've stuck another sheet underneath, just in case. I do think I'll need it. Not all of it, but there's that bit there. And this bit here, I'll just secure a little bit there as well. Okay. Now, last bit of this question. So, it says here, find the true shape of surface A. Now, we've actually a bit of this work already done. What we can do here is we can simply rabat it around. So, if we think of a topic called the oblique plane, where you rabat something, when you can rabat an edge view to find the true shape of the surface. So, I'm going to extend out my x1, y1, because that is representing the ground. And technically, my surface A, which is this surface here, I already have it as an edge view over here. Now, what I want to do is I want to rabat that down so I can look at it on the ground. So I'm going to rotate that surface until it's flat, just about there. You can see why I got the extra sheet. And I've rotated that surface until it's sitting flat on the ground. Now all I'm going to do is I'm going to project it back parallel or perpendicular to the x1, y1. So to the x1, y1, project it back perpendicular. And project that back. And then project out perpendicular from these 2 points to this line, because that's where we're rabatting it over. So that will come out. And this will come out. And technically, if I connect those up like that, that to there, to there, and to there, that area inside there, just all inside here, should be gone that way maybe, that area inside there is my true shape. True shape A. All inside there. And all we did was we rabated around and then projected out perpendicular from this point and this point inside there. There is other ways where you could get kind of true lengths. I've already got the true length of this one, and I've got the true length of this one. You could get the true length of this line here by, how would I do that? Treating maybe this point up here as the apex of a cone, rotating this around, and you could go up here using the cone principle and get the true length, and then you could actually draw it in somewhere blank on your page. Probably would be a little bit neater than how I did it there. as you can see here, I had my sheet set up in a landscape format, a little bit of a gap there at the top, but you can see here, based on the size of the drawing, these questions are designed to be done on an A2 sheet, so on the A3 sheet I just needed a little bit of extra room. Okay, there you go folks, that there was the question C3 from the 2024 mock from Examcraft. Hope you found it helpful. Okay.